Solving equations. We'll go through the quiz that you took in class. So we're just going to start in with those. But remember, before we get started, remember the three things I've always said you have to know to solve an equation. If you know those three things, you can solve any equation you're ever going to be given. The first thing you've got to remember is your goal is to get the variable by itself. All right, you want to get the variable by itself. All right, and then remember you can do anything you want to the equation as long as you do it to both sides. So you can do anything you want to the equation as long as you do it to both sides of the equal sign. All right, to both sides of the equal sign. Okay, and then the third thing is remember opposite operations. Your addition and subtraction undo each other, and your multiplication and division undo each other. So addition and subtraction undo each other, multiplication and division undo each other. So let's just start right here with the very number one on your quiz. Number one on your quiz was h minus 12 equals a negative 27. Again, I want to get the h by itself, so I'm going to add 12 to both sides because what's going to undo subtracting 12? Adding 12, and I can do anything I want to as long as I do it to both sides of the equal sign. So those cancel out, leaving me with h is, and negative 27 plus 12 is going to be a negative 15. Again, I'm not going to do this on every one of these, but remember you can always check these by plugging it back in. Every place there's an h, I'm just going to put in a negative 15 minus 12. Does that really equal to a negative 27? And yes, it does, so you know you've worked the problem correctly. All right, number two, you have c plus 102 equals 36. Again, I want to get the c by itself, so what do I need to do? Well, I got to get rid of adding 102, so what gets rid of adding 102? Subtracting 102, which I can do as long as I do it to both sides of the equal sign. Those cancel each other out, leaving me with 36 minus 102. Well, if you need to write that down over here on the side, you can. That's really like plus and negative. So I'm really going to subtract and take the sign of the larger number, so you get a negative 66. All right, number three, negative 1 3/8 k equals 2/3. Well, first thing I do is I would get rid of that mixed number in there and make that an improper fraction. So I'd make that what, 8 times 1 is 8 plus 3 is 11, so it's a negative 11/8 k equals 2/3. Okay, there's really a couple of ways to approach this problem. The first way you might want to think of is, okay, I got to get that k by itself. I want to get rid of multiplying by negative 11/8, so I'm going to divide by a negative 11/8. Those cancel out, leaving me with k equals, and that's really what, 2/3 divided by a negative 11/8. Now, what do I do when I divide? I've got to flip the second number and multiply. So that's a negative 16 over 33. K is equal to a negative 16 over 33. Now, let me show you another way you could work this problem. If I have a negative 11/8 k equals 2/3. All right, you can divide by, look what happened down here when I divided by a negative 11/8. I really ended up doing what right here? Multiplying by a negative 8/3. Could I not just come up here and multiply by the reciprocal? Basically, that's just what all I did down there. Then these cancel out, right, leaving me with k. And I have 2/3 times negative 8/11, which is going to give me the negative 16 over 33. It's really the same thing. If you just, instead of dividing by that, you just multiply by the reciprocal so that they cancel out. But whichever way makes sense to you, that's the way I want you to do it. All right, number 4 is negative 75 equals a negative 15b. Again, I want to get the b by itself. What's attached to it right now? Times negative 15. So I'm going to divide both sides by negative 15 to cancel out that multiplying. Over there, those cancel out, leaving me with b. And negative 75 divided by negative 15 is a positive 5. Again, remember, you could check all of these to see if you've gotten them right. Number 5, we get into our two-step equations. 2q plus 11 equals 3. Again, I've got to get the q by itself. What's attached to it? Times 2 and plus 11. Remember, we've always said if it's not part of the fraction, get rid of the addition and subtraction first. So I'm going to end up subtracting 11 from both sides. So I get 2q is equal to 3 minus 11 is negative 8. Divide both sides by 2 to get the q by itself. So q is equal to negative 4. All right, moving on, number 6. K plus 9 over 12 equals negative 2. Now, we've talked about this a lot. I've always said, like in the last problem, I said get rid of the addition and subtraction first, unless the addition and subtraction is part of the fraction. That plus 9 is in my numerator. So I've got to get rid of that dividing by 12 first. So I'm going to multiply both sides by 12. These cancel out, leaving me with k plus 9 equals a negative 24. I'm going to subtract 9 from both sides. So k is equal to a negative 33. Okay? Moving on, number 7. 8 plus 5c equals 7c minus 2. Now on this one, I've got to get the c by itself. That's my goal. Okay, we talked about that at the very beginning, but look, I've got a c on both sides. So let's start by getting our c's together. So I'm going to maybe subtract 5c. It doesn't really matter. You could subtract 7c. I just like to keep it positive if I can. So 8 is equal to 2c minus 2. Now I'm going to add 2 to both sides. So 10 is equal to 2c. Divide by 2. And 5 is equal to c. All right, number 8. Look at number 8. 1/3 18 plus 12q equals 6 times 2q minus 7. All right, what have I got to do here? Got to do my distributive property, which on this side of the equation is going to be real easy, right? 12q minus 42. Now over here, what is 1/3 times 18? Well, come down here and do it. 1/3 times, I can write that as 18 over 1. That's really just going to be 6 plus, what's 1/3 times 12q? Again, I can cancel out. That's going to be 4q. Now, once I've done that distributive property, it's just like the problem I did before this. I've got my q's on both sides. So let's get the q's on one side of the equation. So I get 6 is equal to 8q minus 42. Add 42 to both sides. 48 is equal to 8q. Divide by 8. So 6 is equal to q. All right, moving on. Number 9, you've got 8 times 5c minus 2 equals 10 times 32 plus 4c. Doing my distributive property, I've got 40c minus 16 equals 320 plus 40c. Again, I want to get my c's on one side of the equation only, so I'm going to subtract 40c from both sides. But those cancel out, leaving me with negative 16, and those cancel out, leaving me with 320. Can negative 16 ever equal 320? No, so my answer is the null set, which you can write like that. You can put no solution, however you want to write it. There is no number that will make that a true sentence. There's no way. So there's no solution. All right, look at number 10. Same thing here. I've got 4 times x plus 20 equals 1/5 times 20x plus 400. Doing my distributive property, I've got 40x plus 80. Doing my distributive property, 1/5 times 20x. Those cancel out, so I'm just left with 4x plus 1/5 times 400. Again, I'm just going to cancel out. Plus 80. All right, bells should be kind of going off in your head right now when you're looking at that, because why? It's exactly the same on both sides. But let's say you don't notice that. You can go ahead, get my x's together, and I get 80 is equal to 80. Isn't that always going to be true? Isn't 80 always going to equal to 80? Yes, so my answer would be all numbers. All numbers work. Any real number will work to make that a true sentence. Okay, so that was just a really quick review. Again, remember the 3 things that I always say. Get the variable by itself, do anything you want to the equation as long as you do it to both sides of the equal sign, and please remember the opposite operations. Addition and subtraction undo each other, multiplication and division undo each other. Thanks, have a great night. Jesus loves you.